Hello again, dear students. Here we have in the chapter 7, section 3. In that section, we are going to talk about exponential function. You can see that in the exponential function, the important things here is what? Is that something like a len. We say that in the len logarithm function, we say we need many important things. The first, it was graph. Do you remember that? The second was what? The second was domain and range of that function. In the third, we need the properties. The fourth, limit of this function for the exponential function, for example. The fifth one, it was, I think, derivative. The sixth one, it was the integral. Do not forget about these steps in these sections. 7.2, it was like that. 7.3, it will be like that. There we got len of function. For example, we say f of x is equal to len of something. But here we have what? Here we have f of x is equal to a to power x or e to power x. These are functions. The first is the general case. The second, f of x is equal to e to power x, is the special case. When I say the special case, means that if you know about the first one, the second one will be easy. So first of all, as we mentioned, the important things for us, it's the graph. After the graph, after sketching the graph, we know how to find the domain and range. Am I right? Just by the shadow of the graph, we know how to select or how to choose or how to specify the domain and the function. So here we are for e to power x. We have what? We have, so I'm going to talk about that one. We have such function from here to there. It's about to touch the line, but it's not touching. Okay, it's about to touch the line, but it's not touching. So careful. I can draw it for you as like that, more specific. The important things here is that point. Do you remember len? It was reverse of that one. So the important things here is what? When x is 0, y is 1. That's the function. So this is true for a to power x, or it's true for e to power x. When I say a to power x, I mean that. When I say to like 2 to power x, like 5 to power x, understood? So 2 to power x or a to power x is the general form. So maybe sometimes the base, we have a base here. The base maybe is equal to e, maybe is equal to 5, as we have in the second graph. Understood, I say? So this is a general form, and that one is a specific form. Generally, the graph is like that. Generally, a to power x is also like that. You can say it's a to power x. Now, let me give you some notes about the difference. Do not forget about that. Before, we have that function, x to power 2. Now, I have another function, 2 to power x. Be careful. The first one, x to power 2. So I have a polynomial. We recall that function as a polynomial. Do you remember that? But here today we have 2 to power x. The base is number. So in that case, we have exponential function. Understood? So now I'm going to the second. Do you have any question about the graph? No. So I'm going to sketch again and again for you to be in your here. Okay. So let me write down like e to power x, natural exponential. When you have e, we recall as a natural. When we have 2, we say exponential general. So tell me about the domain and the range. Here's the graph, here's the x-axis, here's the y-axis. You know about that one. How we specify the domain and range. Can you tell me? Yalla, domain and range. Exactly. How do you know? Graph. Yes, you're right. So here's the shadow. The shadow over x-axis, oh, that one, the falling of the shadow, you can see start from negative infinite, 0, also positive infinite. Am I right? So that's why we say the function a to power x, the domain is from minus infinity to infinity to where? To infinity. Am I right? Good. How about the range? Exclude 0. Thank you very much. We have such shadow here. This is positive, this is positive till here, but we can see we have no 0 here. That's why we say is exclude. Can you memorize that one? You saw that one before. Where? Can you memorize these numbers? Chapter 1. Of course, in chapter 1 you have that, but it looked like what? Let me write down for you. How about ln of x or log of x? It was like that. Am I right? And the function, it was like that. And here it was 1 and 0. Do you remember that? Hello? In 7.2? Okay, you can see these two functions, or log, let me write log. These two functions, they are inverse to each other. So 7.2 and 7.3, they are inverse to each other. Understood? So log and a to power x, they are inverse. Log with the x and a to power x, they are inverse to each other. Ln and e to power x, they are inverse to each other. When I say the inverse, what do you remember? When you say there are two functions, they are inverse to each other. Give you what? Tell me about that. F inverse of f is equal to what? We have a guess. Come on, say something. ما كل يكلم يانا يعني عيب اشتغلت يلا دي. Good morning. Okay, I get one. You are right, absolutely. So is equal to what? And also we say f circle f inverse of x is equal to the same thing. In the 7.1, yes? Thank you. It was equal to x. Am I right? We say that in the 7.1. Each function, if you take a inverse, you'll get the same thing, right? How we check the inverse? How we checked before? Do you remember? We use that. We use that one. I told you are free for using that one or that one, but we used that one. So here we are. Okay. So for example, let me tell you, log of a to power a x. This means that f circle f inverse of x is equal to x. Understood? Also, I'm going to write also what? Also, you can write like that. A to power log of ax is equal to x. This is the power. That one all is the power. So it means that f inverse circle f of x is equal to x. Understood? How about ln? Can you imagine? Can you tell me about the ln? Ln e to power x is equal to what? The same, x. Yes, you are right. Is equal to x. And e to power ln of x, the same. Understood? Good. So that was about the domain and range and the graph. Now I'm going to limit. I'm going to limit. Limit x approach to infinity for a to power x. Limit x approach to minus infinity for a to power x. So tell me about the value of this one. And how do you know? Don't say it's equal to 2, for example. Show me, give me the clue. X. It's a limit. U is equal to y. Okay. So even I don't know if I'm not sketching the graph. Okay, so you need a graph of that here. Here's the graph, we see that, right? So now I have x approach to infinite. X is going to infinite. Show me the behavior of the graph or the curve when I'm going to infinite. It's going to where? Increasing exactly to where? Positive. Understood? Okay. Show me when x is going to, let's do that one by green. Exactly to where? 0, you're right. When x is going to minus infinity, when x is going to minus infinity, the graph is going to where? To touching the x-axis, means that it's going to y to be 0, shrinking. It's going to be 0. These two limits are very important in the ex or exponential. So the same thing is true for what? For e. Understood? I got with them x approach to infinite, e to power x, or directly write infinite, because they are the same. There is no difference between them. Just we have the base are changed. Understood, dears? So that's about the graph, domain, range, and limits. So what else? Let me check here. Maybe property. I don't know what we have. Here's the graph, you can see. Okay, here's the showing that these are inverse to each other. You can see inverse. And now I'm going to solve that equation. E to power 2x minus 6. Let me write properties, number 4, properties. So we have 2x minus 6 is equal to 4. Yalla, how we solve that one? So tell me first, that one is called what? We call that one as what? Inequality equation, function, which one? We call that one as what? Equation or function or inequality? It's exponential equation, thank you. It's the equation first. Why? Because we have x and equality, right? So that is the definition of the equation. So that's the, but because we have e, as he mentioned, we have exponential equation. Understood? So we have ln equation, we have exponential equation. How's an equation, the formula? For example, I say ln of x minus 1 plus ln of x plus 1 is equal to 20, for example. This is the equation, first of all. Why? Because I have an x and number, but we have a ln. So I am going to recall that one as a log equation, ln equation, okay? We say logarithmic equation. Understood? Hello? Good, good. So that's about that. I'm going to solve the first one. We have e to power 2x minus 6 is equal to 4. So how we solve that one? We should go to use the identities. Which identities? The identities of ln and e together. Understood? Here we didn't get the e still. Later we will get it. But you know about the inverse function. You know about the ln function. So how we solve that one? We are going to take ln. to both sides. I'm going to take ln to both sides, taking ln, okay? Understood? Okay, so I will get what? We have that property, ln of x to power a is equal to what, or to power r? We say r ln of x, am I right? That one will come to here. So in that case, 2x minus 6 ln of e equal to ln of 4. Understood? Do you have any question? Guys, do you have? Easy? Do you think it's easy? Okay. No. No, just we took it. Now we didn't do anything. Yes. We used that one. We used. It's not the same, but we use sometimes like that. Any question about the first step? Okay. Now you know ln of e is equal to what? 1. Ln of 1 equal to what? I'm property 0. Good. So now we have what? We have 2x minus 6 is equal to ln of 4. Am I right? Ln of 4 is a number. We don't care about it. I have no calculator, so I'm not going to find it. During the exam, also, you don't need to. Understood? So now I have an easy equation. I say ln of 4 plus 6. So x is equal to ln of 4 plus 6 divided by 2. This is the equation of exponential that we solved. When we have an equation, we should find what? Find value of x, right? Good. Yes. لاني اي اكس على 1 نو نابت شو عملنا بزانت شي اللي قاعد تكلمه دوي سيلك لك شو دوز توب شانو بسرچا باشا كاكا بسرچا لك شو هاتا برچا بينو بسرچا. Any question about this one? Okay. Now we are going to talk about derivative of an integral. سروقه اخر حل كردو شتي حل كردو كي بردوتا اوبر ولا خويا نعرف لاني a over a equal to 1 over a هاد لي ضربي a كردو امو اما ارون واكات هيك يعني فاليو نيا باشا ولا شتي ترو هات ولا سرو هات ونانو واز لينا بوتا شو ما معنى نيا باشا كاكا. Okay, so we have integral and derivative, the fifth and fourth properties that we see, the important things. Do you have any question before? Okay. So derivative, number 5, derivative, y equal to a to power u. So derivative will be what? Derivative of that one. Listen to, look at here. We have equal to itself, derivative of hat, or ln of the base, derivative of hat. Understood? For example, I have y equal to 2 to power x squared plus 3x. So in that case, I say the derivative is equal to itself, ln of 2, the base, derivative of hat, okay, so it's equal to 2x plus 3. Understood? And careful, do not multiply that one to here. Basha kaka? Issa tabu, issa kafir. You don't need to, this is the angle of, or this is the number of ln. You don't need to multiply it by something else. You get the idea? Good. That's the another point. So together y equal to a2 power u, derivative will be what? Sorry. Derivative will be what, as we said, itself ln of the base u prime. How about e? Look at here, the same. Derivative is equal to itself ln of the base u prime. But you know, ln of e equals to 1. So directly you are going to write down like that. Itself u prime. Understood? For example, the same example, if y equal to e2 power x square plus 3x, directly I say the y prime is equal to itself 2x plus 3. There is no ln of e. You don't need to. So you don't need to memorize it. You can write down here. Later, you can eliminate it. Understood, dears? Do you have any question? Can you find this one for me? Y equal to 2 to power sine of x, then find y prime. Can you do it? So y prime equal to 2 to power sine of x, okay. Ln of 2. Let me change that on to 3, okay? So ln of 3 cosine of x. Thank you. Easy, right? That one's very important because later I have what? Integral. Careful. Do not forget about that. So let me show you or share with you these examples. I think these all are easy for you. Even that one, you can imagine. Look at it, please. Can you imagine that one? Yes, easy. It is equal to itself, derivative of the hat, which is -1. Understood what I say? Understood, dears? So easy. And you solve that one, harder than that one. So here we are. Now we have integral. Do you have any question? Okay. So I'll talk about the integral, then I'll give you a rest. So okay. So we talk about that one. Now the integral time. The last one, it was integral. It was number 5 and number 6. I don't know. How many property we wrote? How many things? I don't know. 6. Okay. Anyway, maybe 5, 6. I don't know. The important things: the graph, the domain, range, limits, properties, derivative, and integral. So for integral, generally speaking, if we have a to power u, and we have du, means that hat d hat. Okay, hat d hat. This one will exist. So directly we can write like that. We say is equal to itself divided by ln of the base, any number, plus c. Example to understand, we have a to power or 2 to power x square. So now I have, let me like that. Now I have 2x plus nothing dx. So where's hat? Where's hat? Hat. So derivative of here is equal to what? 2x dx. So hat d hat. Okay, and I'm going to write hat d hat. Understood? So directly I will answer like that. 2x squared plus 3 over ln of 2 plus c. It's easy. So tell me about the other example. E to power. That's not easy. First, tell me about 3 to power sine of x cosine of x dx. That one is equal to what? Yalla. Let me know you understand or not.
3 sine over ln of 3 plus
3 sine ln of 3 plus c. Why? Because derivative of sine is equal to cosine. Last example on A. Write down 3 x squared minus x squared plus 2 x dx. Yalla. Okay, 3x squared plus 2. Okay. Ln. Okay. Yes, we need minus 1 over 2. Okay, so we need minus, it's okay. Nothing changed here. We need, sorry, minus 1 over 2 here and minus 2 here. Am I right? Now, so we are going to multiply by Basha. Understood? So it's very important. Now tell me about that one. جربها بس simply this بيبكم. ما easy. It's a special case as a previous one. Special case. Exactly. So in general form, if we have e to power u du hat, so directly I'm going to write itself plus c. We don't need ln of e. You can write down ln of e, but you know is equal to 1. So that's why I'm going to erase. Thank you for being with me. So I am going to write like that. E to power x dx. So tell me about that one. Is equal to what? Yes. We need derivative of here minus 1. Am I right? So we are going to multiply by minus 1 is equal to itself plus c. Understood? Okay. Last example for the first term, is equal to what? E to power. Understood? Okay. I'll give you a rest.